Now we're gonna see the empirical and molecular formula of the unknown compound and how to calculate the empirical and molecular formula, and then to solve the stoichiometry problem involving limiting reactant. So we're gonna learn much more on calculation on this part. Okay, first thing first, what is atom? Atom is, everyone knows, the smallest unit of the element that can take part in the reaction. It can combine within itself or combine with another atom to form molecules. We also have subatomic particles. In an atom, it has proton, neutron, and electron. Those three things that we call as subatomic particles. Alright, so proton symbol is P, neutron N, and electron is E. So proton and neutron normally both are seated in the nucleus, but electron normally the one that round up the nucleus, outside the nucleus. Right. So charge for electron is minus, charge for proton is positive 1, neutron is 0. Okay, this is the actual mass, 1.6710 power of 27 for both proton and neutron. Alright, while for electron is 9.11, okay, power of 31. Alright, so look at this one. This is how atom structure would be. It would be proton and neutron, okay, in the nucleus, while it has electron, okay, rotating the nucleus. Alright, so the charge, if you look at here, proton and neutron, they are in the nucleus, okay, right? Okay, and then proton is positive, neutron is 0, which is neutral, and electron is negative to balance back the charge of positive. Alright. So, subatomic particle, normally a proton have positive charge that is equal to the electron's negative charge. If you have positive ones, so basically electron also have negative 1 to balance it back. If you have positive 2, you have electron of negative 2 charge. Okay. So in atom, number of proton is equal to number of electron, where it is neutral. Okay. So it's very small. Most of the mass is in the nucleus. Alright. So this is how we recognize the atomic symbol. Okay, atomic symbol, normally if you look at your periodic table, you have X like here, and you have A and Z here. Okay, A is the mass number and Z is the atomic number. Don't be confused, or don't be confused about them. Right, so X is atomic symbol of the element. Z is the atomic number, which is number of proton in the nucleus. Okay, as we know, number of proton is equal to number of electrons. Alright, so A is equal to Z plus N. A adalah mass number is equal to Z atomic number plus neutron. Okay. Okay. Number N adalah number of neutron. Okay, these are the example how to calculate number of proton and electron. Always remember that number of proton ataupun mass atomic number is always equal to number of electrons. So if this value bring the number 6 for proton, so it's also bring number of 6 for electron. So proton and electron always refer at the down here. For neutron, this one, A minus Z, we got the number of neutron. Okay, the one that circle the nucleus. Right, proton and electron always have the same number. Okay, both of these has the same number. Where you should refer at this one, atomic number. Okay, right. Okay, so next example is like nitrogen. Nitrogen has 14 mass number and 7 atomic number. So this is bring the meaning for proton and electron. Both are 7. Okay, both are 7. But for neutron, you have to minus. 14 minus 7 is equal to 7. Alright, for this one, proton and electron for bromine is 35. So both are 35. Okay, and then for neutron is 80 minus 35 is equal to 45. Okay, for proton and electron for phosphorus, phosphorus is 15. So 15 for both, and neutron is 16. 31 minus 15 is equal to 16. Easy to remember. So next is isotope. You should know that atom, it has many isotopes. Okay, it has the same number of atomic number but different mass number. Meaning atomic number is down at the bottom, but mass number at the above they have different number. Okay, so for example, hydrogen. Hydrogen we have 3 isotope. Isotope 1. So this is the number of mass number is different. 2 and 3. Okay, if it has one number of mass number, we call it as protium. If you have 2 mass number, deuterium. If you have 3 mass number, tritium. Okay, so atom with the same number of proton but different number of neutron. Yes, correct. Proton and electron will be similar but neutron will be different. It has similar chemical properties but have different physical properties. Okay, they are all hydrogens. So basically chemical properties are different, but their physical properties might be different. For example, you have triplet of 1, 2 and 3. They have chemical properties. They are chemically look similar but their physical must be different. Might be someone is taller, someone is a bit not that short, okay, then someone is shorter. Okay, for example, hydrogen has 3 isotopes as named as that. Okay, alright. So mass of atom, we cannot weigh single mass of atom directly, but we can determine the mass based on atomic relative number. Okay, first we need to assign the value of mass of one of the atom of the given element so that it can be used in standard. Okay, look at this one. Normally, mass of atom we cannot weigh, but we can express in atomic mass unit. Atomic mass unit, which is AMU. Okay. This is based on the system that has been come out in 1961. Okay, where it says that carbon have C12 as standard. So we always refer to carbon C12 as a standard in order to calculate the atomic mass. So one atomic mass unit, AMU, is defined as mass exactly 1/12 mass of the carbon atom. So we can say that C12 atom is equal to 12 AMU. Okay. So carbon isotope, it has carbon isotope of 6 proton, 6 neutron. 1 C12 has set to 12 AMU to provide the measuring unit. So look at this one. Look at the example, the question first. Experiment has shown using mass spectrometer that the hydrogen atom only consists of 8.4% of the massive C12 atom. Therefore, a relative atomic mass of the hydrogen atom is, in order to calculate the AMU, you have to put the percentage over 100%. If you're given in percentage, so you put 8.4 over 100 times by 12 AMU is equal to 1.008 AMU. So this is the significant figures that you put in. Okay, so when it says that it has C12, this is not ended yet. Okay, so when 12 carbon and 13 carbon, because carbon have 2 different isotopes, carbon 12 and carbon 13. Okay, are analyzed by mass spectrometer. Mass spectrometer normally function, it can distinguish between the number of isotopes. If let's say we put hydrogen in, and then it can distinguish that there are 3 isotopes of hydrogen separately. Alright, so by that you can determine the relative atomic number. Okay, right. So for carbon, it detects 2 isotopes, carbon 12 and carbon 13. The relative ratio, their mass is found to be mass of carbon 13 over 12 is equal to 1. This is the relative ratio. Just the ratio. So now the question is how we want to determine the AMU, atomic number of the carbon, because this one is calculated for 1% of C12, but somehow it found it has 2 isotopes here. So you cannot neglect 13 as well. So this is have to be calculated with using mass of this. Alright, so how you do it? Okay, if you put 13 over 12, you got a ratio of 1.083619. That will be times by 12 AMU, referred to AMU, atomic mass unit for carbon. So you got 13.003355, which is equivalent to 13 AMU. This is only accurate because you consider this one only consider for 12 AMU. for one carbon. But when we know that it has two isotopes, we have to divide with the higher isotope over lower isotope, then only you can get the relative mass. It's just like you do the mean, find the average. Okay, if you have two isotopes, you have to find the average. Then only you calculate with 12 AMU. Okay, alright. Okay, so next, how to find the average atomic mass. So the value is not always 12, but it's always like 12.01 AMU for atomic mass of carbon. The reason because it has more than one isotope. So this is why, let's say carbon has 3 isotopes. Okay, carbon 12, carbon 13, and also carbon 14. But carbon 14 is normally negligible because the number is really small. Mostly we found isotope of 98.89% of C12. C13 we found around 1.111%. That's why carbon 12 is nearly negligible because it is too small. These two already combined, when you combine it become 100 already, nearly 100. Okay, so C12 bring 12 AMU, C13 bring 13 AMU. This one negligible, so you don't need to calculate. So look at this one. How to calculate average atomic mass of 98% of this one. Okay, let's say 98.89%, you times by 12 AMU, while 1.11% times by 13 AMU. So you times up, you plus these two, you got a number of 12.01 OMU. So I've mentioned just now, every time we say atomic mass, it means average and relative atomic mass. Okay. Alright, so next, this is a sample problem. Try this. Silver Z number, that's this number at the bottom, is 147. Okay, so Z means what? Number of proton and electron. Similar, 47. Naturally occurring, it has two isotopes, 107 and 109. Give the mass spectrochromic data. Calculate the atomic mass of AG. So how do we calculate the atomic mass? Right. Okay, this is number of 107. This is A number. Okay, A number. 109 A number. This is Z number at the bottom. Alright, so 107 and another isotope is 109. So the AMU that you calculate is 106.9. This time by 12. Okay, so you got this one and then you got this one as well. So relative abundance is given as that. Okay, so how do we calculate the atomic mass? Atomic mass is equal to AMU times by how many percent? You convert it into decimal places, 0.5184, and then plus with 108 times by this value. It's always calculate with the percentage. Okay, calculate these two only. Okay. So that's his times. Okay, you calculate these two only. This one and this one. And then you plus them together, you got 107.87. Okay, in the mass of gram, 1 mole of substance, molar mass is of C atom is numerically equal to the atomic mass of AMU. Atomic mass of carbon is 12.01. Molar mass is sama. Okay, 12.01 gram. So we convert, we assume there are similar gram. So if you have nitrogen, 12.99, so it's equal to 12.99 gram. So molecular mass, okay. Okay, molecular mass, if you have compound or elements, okay, so you have to calculate everything because we have 4 hydrogen number here. You have to calculate everything. You cannot calculate on a single atom only. You have to calculate on all of the compound. So let's say we have 1 carbon atomic mass times by atomic mass of C, which is 12.01, plus with 4 atomic number of hydrogen. Atomic number of hydrogen is 1.008. So that's giving you 16.04 AMU. That is equivalent to 16.04 gram. Okay.